something like this. We get a little tougher. We got a little bit weirder going on here. Okay, so when we get something like this, I see a couple things. I see more than one trigonometric function. I see a squared in there, and I see that it's cosecant. I'll work with it like this, and I'll only convert this cosecant back to sine at the very end. That's the last thing I'm going to do. I want to work with this right now. Check out this. See if you notice something here. Notice if I write it like this, if I write 2 and then I use big brackets, because cosecant squared really means it's cosecant, whoops, let me erase that. It's cosecant x, and then it's really all squared. This is what it means. And then that's that first term. If I add cosecant x, like that's the second term there, and then I subtract 1, that equation looks like that. Now, does this look familiar at all? Like, I know there's cosecants in there, but if it looks familiar, I got 2 times something squared plus that same something minus 1. Let's see what happens here. Notice if I say let k, say I let k equal this cosecant x. Alright, so I'm going to take the cosecant out and put in k. Here's what my function looks like when I do that. Notice I'm substituting this, okay? So this is kind of a little trick we can do. So look, this is 2 and then cosecant squared. So this is 2k squared, right? K is the cosecant x plus that cosecant x is a k, so it's plus k minus 1 equals 0. So my equation looks like this. And what's this look like? A quadratic expression. How do I solve quadratic expressions? I factor them, I set them equal to 0, which is already is, and I solve. Okay, so I'm going to factor this. This is got the 2 in front, this is a decomposition factor, so I'm looking for 2 numbers that multiply to negative -2, and they add to 1. Anybody know those numbers? Multiply to -2, add to 1. How about plus 2 and not minus 1? So I replace the middle term with the 2k, subtract the k. So I'm factoring by decomposition here. Our next step to factor by decomposition is to do grouping between the two sets of terms and common factor. 2k comes out of the first set. What's left? A k plus 1. What's common here? A minus 1 comes out of those two. What's left? A k plus 1. K plus 1 is the common factor between these two. This comes all out. I got k plus 1 times the remainder. What's left? 2k minus 1. Alright, so notice this expression turned into this expression, and now to solve this, I solve each bracket to be 0 when we're solving, say, quadratic expressions. So I've got k plus 1 equals 0, or 2k minus 1 equals 0. Okay, I'm going to take these and I'm going to move them to a new page to give me some new space here. Okay, so I've got these basically now I have these 2 equations to solve. Okay, so the first one was k plus 1 equals 0. The other one was 2k minus 1 equals 0. So let's solve the first one. If I solve the first one, k has to equal minus 1. Solve this one for k. 2k equals 1. K equals a half. Okay, so here's my 2 solutions for k. This solves the polynomial equation, but remember k was cosecant. So this is cosecant x, right? So I'm substituting back in. K is cosecant x, and then that equals minus 1. And if I substitute cosecant x back in for k here, I got cosecant x equals a half. Now why I did that is because when I look at this equation back here, this was super ugly. And what I did was transform it into something I know. I can solve this. And then I can put the k back in. Because now I can solve each of these, right? So now I can solve what cosecant equals to minus 1. I can figure out that angle. So let's solve that one there. Cosecant x equals minus 1. It's cosecant equals minus 1, so I'm going to turn this into sine. So if cosecant x equals minus 1, what's sine x equal? Well, the reciprocal of that. Since it was over 1, I flip that, it's still back to negative 1. So I've got this equation to solve. Let's do the same thing over here. If cosecant x equals a half, what's sine x equal? Well, you flip that one, you got 2 over 1. So this says sine x equals 2. So this is the other equation to solve. Look at this one first. Is this solvable? Does sine x ever equal 2? No, sine's max is 1. So this one has no solutions. Which means there are no solutions to this equation, right? There's no value of x that makes that little equation there true. Does sine x ever equal negative 1? It does. It does at its minimum, right? That's its minimum. Think about the circle. When is the y value? Sine is the y value. When is the y value negative 1? There it is down there. And that's at 3 pi over 2. That's the only value between 0 and 2 pi. So the only solution between 0 and 2 pi is 3 pi over 2. That's the only solution to this equation. Okay, I recommend you maybe to rewatch this, rewatch any of the examples that you need to. Your goal here is to solve the equations for homework and in class also.